There's a moon in our solar system that breaks every rule. It's larger than an entire planet. It has something no other moon in the solar system has, something it shouldn't have, its own magnetic field. And beneath its surface, scientists believe hides one of the largest oceans in the entire solar system. Not on Earth, not on Mars, not anywhere we expected, on a moon. And yet, almost nobody talks about it. Just silence. And that silence might be the biggest mistake we've ever made, because we were too busy looking somewhere else. We had our obsession. We had Europa. And while all eyes were there, the largest moon in our solar system was sitting right next to it, bigger, older, more complex. This is Ganymede, and it might be everything we thought Europa was, everything we thought Earth was, and more. For most of human history, we looked up at the night sky and saw points of light, distant, unreachable, unknown. Then, in 1610, a man named Galileo pointed a telescope at Jupiter and found something nobody expected. Moons. Not one, not two, but four. Four worlds orbiting a giant planet. He named them the Galilean moons: Io, Europa, Ganymede, Callisto. Four worlds, four different stories, four different secrets. And for 400 years, we've been trying to understand them. Io, the most volcanic place in the entire solar system. Constant eruptions, constant destruction, a world that never stops burning. Europa, the moon with the ocean, the one everyone chose, the one everyone obsessed over. Liquid water beneath ice, the dream of life. Callisto, the forgotten one, ancient, unchanged, hiding its own secrets in silence. And then there is Ganymede, the one that doesn't fit, the one that breaks the pattern, the one that should be just another moon, but isn't. Let's start with the basics, because even the basics are extraordinary. Ganymede is big, not moon big, not just large for a moon. Ganymede is larger than the planet Mercury. Let that settle for a moment. A moon bigger than a planet. Not slightly bigger, not comparable. 8% larger than Mercury in every direction. If Ganymede were orbiting the sun instead of Jupiter, we wouldn't call it a moon. We would call it a planet. A full planet with its own classification, its own status, its own place in textbooks. But it doesn't orbit the sun, it orbits Jupiter. And because of that, it gets called a moon. And because it gets called a moon, people assume it's small, unremarkable, just another rock in space. They're wrong. Because here is where Ganymede stops being interesting and starts being impossible. Every planet we know that has a magnetic field generates it the same way. A liquid metallic core rotating inside the planet, creating an invisible shield around everything. That shield deflects solar wind, protects the atmosphere, makes life possible. Earth has it. Jupiter has it. Saturn has it. Moons don't. Moons are too small. Their cores cooled too quickly. Their interiors solidified. The rotation stopped. The shield disappeared. Our own moon had one billions of years ago and lost it. Mars had one and lost it. Every moon we've ever studied either never had one or lost it long ago. Except Ganymede. Ganymede still has it. Right now. Active. Working. Protecting. A moon with a magnetic field that has no right to exist. Scientists call it
an intrinsic magnetic field, meaning it comes from within, from Ganymede itself, not borrowed, not reflected, its own. And it creates something almost poetic. When Ganymede passes through Jupiter's massive magnetic field, the two fields interact. Jupiter's field pressing inward, Ganymede's field pushing back. And at the poles, something extraordinary happens. Auroras. Not on Earth, not on Jupiter, on Ganymede. A moon creating its own auroras. Ribbons of light dancing at the poles of a world that shouldn't be capable of it. The Hubble Space Telescope confirmed it in 2015. Real auroras on a moon. And that discovery changed everything. Because those auroras weren't just beautiful, they were a message, a signal telling us something is happening inside Ganymede, something active, something alive. And when scientists looked closer at what could be causing a magnetic field this strong, they found something else, something hidden, something vast, something that made every previous theory feel small.
Beneath the ice, beneath the rock, deeper than anything we had expected to find. An ocean. Not just any ocean, the largest body of liquid water ever discovered, anywhere. Not on Earth, not on any planet, on Ganymede. And the question that nobody had thought to ask was suddenly impossible to ignore. If Ganymede has a magnetic field that protects it, and an ocean that could support life, why have we never sent anything there?
That ocean is not a small discovery. Scientists estimate Ganymede's subsurface ocean contains more liquid water than every ocean on Earth combined. Every river, every lake, every sea, every drop of water on our entire planet, Ganymede has more. And it has been there for billions of years, stable, protected, undisturbed. Now think about what that means. We've spent decades searching for liquid water beyond Earth, because water is the foundation of life as we know it. Mars lost its water billions of years ago. Venus burned, Mercury dried, the moon never had enough. But Ganymede has been quietly sitting there with more water than Earth this entire time. And nobody sent a mission, nobody drilled, nobody looked closely enough because it didn't look exciting, because we had Europa, because we had our favorite, because we stopped asking what else is out there. But here's what makes Ganymede truly different, truly special. It doesn't just have water, it doesn't just have size, it doesn't just have auroras, it has protection. That magnetic field we talked about earlier, it does something no other moon can do. It shields Ganymede from Jupiter's radiation. The same radiation that makes Europa so dangerous. The same radiation that breaks apart molecules, that destroys complexity, that resets everything. Europa sits inside Jupiter's radiation belt, constantly bombarded, constantly damaged. But Ganymede sits in its own bubble. Its magnetic field pushing Jupiter's radiation away, creating a zone of relative calm, of stability, of protection. Liquid water, magnetic protection, billions of years of stability. These are not small things. These are exactly the conditions we look for when we search for life. And yet, we still don't know. No lander has touched its surface. No probe has penetrated its ice. No mission has reached its ocean. Ganymede has been waiting 4.5 billion years for someone to come and look, and we haven't. Maybe that changes soon. The ESA's JUICE mission, launched in 2023, is heading to Ganymede right now, arriving in 2034. For the first time, we will see Ganymede up close. For the first time, we will take its secrets seriously. Because maybe we've been asking the wrong question this whole time. We always asked, where is life most likely? And we pointed at the obvious, the dramatic, the loud. But Ganymede asks a different question. Not where is life most likely, but where has life had everything it needs for the longest time? Water, protection, stability, time. Ganymede has all four. And in a solar system full of violent, beautiful chaos, sometimes the answer isn't the loudest world. Sometimes it's the one that has been ready the whole time.